Welcome to this tutorial. In this video, we will be building a crowdfunding platform on Ethereum. This is an exciting project that combines Solidity, smart contracts, and Web3 technologies. By the end of this video, you will have a fully functioning crowdfunding application. Let's get started. First, let's define the main requirements of our crowdfunding platform. We will need to create a smart contract that allows project creators to fund their projects and backers to invest in these projects. Some features we will include are creating a campaign, funding a campaign, and withdrawing funds for the project creator. Our contract should also keep track of supporters and their contributions. Let's start by setting up our development environment. We'll be using the Truffle framework, which makes it easy to develop, test, and deploy Ethereum smart contracts. First, make sure you have Node.js installed on your computer. You can check this by running Node v in your terminal. Once you have verified Node.js is installed, install Truffle globally by running the following command in your terminal. Next, let's create a new directory for our project and initialize a Truffle project inside it. Now that we have our Truffle project set up, the next step is to create our smart contract. Inside the contracts directory, create a new file named crowdfunding.sol. Let's define the structure of our smart contract. We will need to import the OpenZeppelin library for safe math operations. Add the following code to crowdfunding.sol. In this code, we defined a campaign, struct to hold all necessary details related to a crowdfunding campaign. We have also created a mapping to store multiple campaigns and a counter for the total number of campaigns. Next, we need to implement a function for creating a new campaign. This function will allow users to input the title, description, target amount, and duration. Let's implement that now. Now, this function checks that the target amount is greater than 0 before proceeding. It then creates a new campaign, stores it in the mapping, and sets the relevant details. Next, let's implement the function for making contributions to a campaign. We'll also track each contributor's amount. In this function, we ensure that the campaign has not ended and that the contributor is sending a positive amount of Ether. The contributed value is then added to the total collected and the individual contributor's amount. Now, let's add a function for the project creator to withdraw the funds if the campaign is successful. Here, we have 3 conditions to check: that the one withdrawing is the campaign creator, that the campaign has not already completed, and that the target amount is reached. If all conditions are met, the funds can be transferred. Let's also add a function to check the status of a campaign so users can see if they have successfully funded the campaign. This getter function returns all necessary details of the specified campaign, making it easy for potential backers or creators to view its status. With our contract fully defined, let's write some migration scripts to deploy it. Create a new file called to_deploy_contracts.js under the migrations directory. This script tells Truffle to deploy our crowdfunding contract to the Ethereum blockchain. Next, we need to configure our local Ethereum network. We'll be using the Truffle Develop network for our testing purposes. To start the local Ethereum network, run the following command in your terminal. With the development console open, let's migrate our smart contract by running the following command. After the migration process, note the address of your crowdfunding contract, which will be used for testing our functions. Now, let's test our smart contract functions using the Truffle console. Start by entering the console, if you haven't already. We will start by creating a new campaign. Use the following command, replacing the values with your preferred title, description, target amount, and duration. This command creates a campaign and should return a transaction receipt if successful. You can then check the campaign count to see how many campaigns exist. With a campaign created, let's proceed to contribute to it. Run the following command, specifying the campaign ID and the amount you want to contribute. Repeat this step using different accounts to simulate multiple backers contributing to the same campaign. Now, let's check the total collected amount for our campaign. You can do this by retrieving the campaign details using the getCampaign function. Once funds have been collected and the target has been met, let's simulate the creator withdrawing the funds. Now, if you check the campaign again, you should see that it has been marked as completed, and the total collected value should no longer be withdrawable. And that concludes the smart contract portion of our crowdfunding platform. We've managed to build a basic but functional crowdfunding system on Ethereum. Next, let's take a look at how to integrate this functionality with a front-end application. We will be using React.js to create our front-end. If you don't have it installed, you can set it up quickly by running. Once your React app is created, navigate to the src/directory and replace the content of the app.js file with the following code. This will set up the UI components for our crowdfunding platform. In this component, we connect to our Ethereum network, load our smart contract, and fetch all campaigns to display them. Next, let's update the package.json file to add a script for serving our React app. We have added a script to run both the React frontend and the local blockchain concurrently. For that, you'll need to install concurrently. Run. After this, you can run the entire application using. Your crowdfunding platform is now up and running. You can interact with it via the frontend we built and the smart contract we created. Try creating a campaign, contributing to it, and see the transactions happening in real time on your local network. In conclusion, we've successfully built a basic crowdfunding platform on Ethereum. You now have a strong foundational understanding of how to create smart contracts and connect them with a front-end application using React. There's a lot of room for improvement, such as adding features for tracking contributions and displaying active campaigns more effectively. Thank you for watching. Don't forget to like and subscribe for more programming tutorials. If you have questions or need clarification on any part, feel free to leave a comment down below. Until next time.